Hello guys, welcome to Code with BK. So in this video we solve the problem to set the ith bit in an integer n. So in the first half I'm going to explain you the steps to solve this problem, and in the second half I'm going to explain you the code. So if you're someone who's just looking for codes, the links to the codes provided in the description of this video, and to each link there is a text explanation as well. So if you're someone who wants to read and understand, you can take a look at that as well.
Please do not forget to subscribe to this channel and click on the bell icon to receive all the latest updates.
So what do I mean by setting the ith bit in an integer n? So let's take an example of int n as 27. So the integers in computer science are stored as 32-bit values. Okay. So the binary form of 27, that is the corresponding binary value of 27, is 11011. Okay. Since an int will use 32 bits, these are 5 bits. So these are padded with zeros on the left. So these will be 27 zeros, okay, and these are the next 5 bits. Bit number starts from the rightmost, so this is bit number 0, bit number 1, bit number 2, bit number 3, 4, 5, and so on, bit number 31. So if for n equal to 27, which has this binary value, I want to say set the ith bit where I equal to 2, so basically set the second bit. Now what do I mean by setting a bit? That is setting the bit number I equal to 2 to 1. So I want this to change to 270011. Set bit number I, that is change bit number I to 1. So changing bit number 2 to 1. Okay. So this is equal to 31 in integer. So when you set I equal to 2, okay, second bit, set second bit in this value n, you get 31. Okay. And this is the problem we solve. So how do we achieve this? From this, for this I equal to 2, okay, we see how. So let me write the bits for n equal to 27 here. So n equal to 27 is 11011. So these are 5 bits, okay, and these are 27 bits, okay, total of 32. Bit number 0, 1, 2, 3, 4, 5 and 31. I equal to 2, so basically I want to set the second bit, okay. So I'm going to take a value whose second bit is 1 and all the other values are 0. So a value whose second bit is 1, all the other values are 0. So we will see in a moment how we construct this value, but for now we take this value and we find the OR, which is the pipe symbol. So we know the rules for OR: 0011, okay, 0101, okay, A or B, okay, 0 plus 0 is going to give you 0, and if any of the two ones is 1, you get a 1. So we have to perform the bitwise OR of these two values, okay, bit by bit, okay. So 1 or 0, that is 1 plus 0 is going to give you 1, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, and 0 plus 0 is going to be 0 for all these 27 zeros, okay, and these are the 5 bits. So in this value n equal to 27, which has these bits, I was able to set the second bit to 1, okay, and all its other bits remain the same. So using this value, we got this from this, which was our aim initially. So this is basically 31, which we wanted. So now our job is basically to construct this value and find the bitwise OR with this original value n. So let us call this value x. So how do we find x? We have to set the bit number I to 1 and all the others to 0. So I start with x equal to 1, which is basically in binary form all zeros except the last one as 1. So these are 31 zeros and this last bit is 1. Then we left shift this x by I places, because I equal to 2 and we want 1 in bit number 2, okay. So this is left shifted by 2 places, so 1 shifts left to 2 places. So this is basically 29 zeros, 1 and 0 0. So 1 which was at bit number 0 comes at bit number 2 now, and everything to the right of 1 is padded by zeros. So 29 zeros, 1 0 0 makes it a total of 32 bits. So in order to get this value x, which has 1 at bit number I and all the other bits are zeros, we start with x equal to 1 and then left shift x by I places. So this left shift operator is provided in programming languages, okay. So if we call this y, okay, so this is basically n or x. So this is the method we use to solve this problem. So writing this into a pseudocode now, so I say function set ith bit takes in the value n and I it sets the ith bit in n to 1 and returns the updated value. So our job is to first find x, which starts with 1. So x starts with 1. We left shift x by I places. X is x left shift I places, and then we return the bitwise OR of n and x. So I say return n or x, and this is our function. So let's take another example where we want to set I equal to 5. Okay, set the fifth bit. Okay, so we take 1, these are 32 bits, left shift it to 5. Okay, so 1 was at bit number 0, comes at bit number 5. Okay, so it becomes, okay, bit number 0, 1, 2, 3, 4, 5. Okay, and till 31. So this is 1 shifted left to 5 places. And then we OR this with original value of n, which is 1, 1, 0, 1, 1. So performing bitwise OR of these two values, okay, I say plus, or you can use the pipe symbol. Okay, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 1 is 1. So we were able to set the fifth bit of this value n to 1, okay, and all the other bits remain the same. This becomes the value 59. So this is how you set the ith bit in an integer n, okay, and now we move on to codes to see how we implement this.
So this is the implementation of the solution we discussed. So I've written a helper function set ith bit that takes in I and n and sets the ith bit in n and returns the updated value. So in my main I have n equal to 27 and I'm going to set the second bit. So I is equals to 2. So I'm printing the original value of n and then the value after you set the ith bit in n. So let me run this. Java C, Java, and okay, setting bit number 2 in n gives you 31. So I will use this code to convert decimal to binary that I discussed. I'll also link the video where I describe the solution. So this will print the binary form of n. So for this we can print n in binary, decimal to binary of n, and then what we do is we print m, which is setting the ith bit in n, okay, and printing this in binary. Okay, alright, so compiling, running. So n is 27, 27 in binary is this, setting bit number 2 in n is 31. So bit number 2, 0, 1, 2 is set and 31 is 1, 1, 1, 1, 1. Okay, so let me set bit number say 5, okay, in 27, and let's see. Okay, 27 in binary is this, setting bit number 5 in 9 we get this. So basically the 1, 1, 0, 1, 1, so the leftmost bit, okay, which was 0 was set to 1. Okay, so I hope this video was helpful. So please do like this video and subscribe to my channel for more such videos, and please let me know in the comments if there is anything not clear to you in this video, if there is a question you want me to solve, or if there is a concept you want me to discuss. Thank you.